Hello there, this is Anil. Today I'm going to show you a mock interview which I took last week. So one person reached out to me on my email ID. I've seen your Tesco interview. It will be great if we can meet for a mock-up interview. And I said yes because this was first time experience, and if it is helpful for the community that I'm trying to build, it's great. So I we set up a call. We went on a Zoom call. I'm going to show you how this interview went through, and I would request if you are interested for similar mock interviews, you can write down to my email ID. That's educationtatva@gmail.com with along with your resume, and we can set up a time to have your mock interview. This will be helpful for you as well for others who are preparing for interviews. Hello, Jatin. How are you?
I'm good, thanks. How are you?
So, Jatin, this will be a mock interview, and we will be discussing on system design, specifically for a problem statement. And I would request you to share your screen and maybe just use tool like draw.io so that we can start. I'll give you problem statement first. On this system design, I want you to design a video streaming app, right? So maybe you can just share your screen and open up a notepad so that you should be able to record what I'm saying.
Yeah. So it is just a video streaming app, is it?
Yeah, that's a video streaming app, and I will give you further details about the NFRs.
Can you enable the screen sharing?
Oh, sorry. Yeah, I just make you the host. So basically,
Okay. I think I'm able to share it now.
great. So Jatin, I will just start with the problem statement. I want you to design a video streaming app very similar like on Instagram. You have Reels feature, right? So first, how you will design the Reels feature and the ratio of content creators versus content consumers is 1:10. So there are, for example, if this application has 1 million user, out of that 1 million user, only 1% of those create content, whereas 10% of them is the ratio of 1:10. So the 10 ratio is more who are consuming the application or consuming the content. So that's the first requirement. Second requirement is it should be a global application. It
Mm-hmm.
should be a global application. Third is it should it should be a non-blocking experience for the user. That's most important. So if the user is uploading multiple videos, they should not be blocked.
They should not be, just to clarify, they should be able to parallelly read or stream the videos which they have
So
already.
when I meant with block, it means like there could be internet break in between, right?
Right.
User should not get that like they should not restart that upload part. Rather than once it is queued for uploading, whenever internet is available, it should be queued up, right? User should not have a
Okay.
block in terms of like a user experience. If I uploaded a video,
Mm-hmm.
irrespective of how many time my internet gets disconnected, at the end
Mm-hmm.
the video should be uploaded.
Okay. And it should start from the point where it has left earlier.
Right, that's correct.
Okay. So I will just write down the requirements.
Sure.
So the video streaming app uh, should be able to support viewing the videos
Right.
which is already uploaded, and uh, should uploading the new videos,
Right.
and it should be a uh, global app.
Right.
The system should be able to record that. Suppose you are viewing an video and you left it in between, so the system should be able to record the point at which you left the video, and from there on it should be able to further show you the video.
Right. And Writer versus reader ratio will be 1:10.
Yeah, recording of the points where the video was seen last. And it should be a global system. Like how much how much should I assume that the one video size will be
You can
on an
assume,
average?
obviously you need to, that's a very good question. Actually, you might need to convert the video, right? Because the video, when someone is recording the video, it could be in HD recording, or it could be in just like in a ratio where it is not so space heavy, right? To not be
Yeah,
taking a lot of
SD or
bandwidth,
HD. So
right?
these two
LD
kind
or
of
SD.
formats in which
So, but ultimately, the video which should be streamed from application, that should be converted in a compressed format. So that compressed format, you can assume that a video of 30 seconds should be of maybe 1 MB,
okay,
right? So which means at the time of video upload, you need to do the compression so that it should be compressed and saved in a storage efficient manner.
yeah, like system should be highly available.
Right.
Uh,
It may not be consistent, but it should be highly available.
yeah, highly available. Eventually, is there kind of a expiry time in which like user should be having the ability to delete their videos which they have already uploaded?
So
Should we
that's maybe
focus
the
on
next
that as
level of
well?
detail, but maybe just from the time perspective, we will just keep it simple. Once the video is uploaded, it is compressed and available for next user to view. Next thing which I want you to take care of, if I've subscribed your video, right? If I have subscribed your, for example, Instagram page, I should also get the notification. So how that notification and how you will manage the subscription, that is also important.
Okay, and video should be searchable by a text string, something like that.
That's okay. That's okay. Not necessary in this MVP.
Okay, subscription
Subscription based notification.
uh, follower should create a notification for the where one video is loaded. It should be reliable, and the most important requirement is here. So while viewing the video, of videos, no latency. Uploading should start from the point where it was last. We'll go on to the uh, ballpark point estimations. Videos will be of duration on an average of 1 minute, and they will be around 100 MB in size.
No,
Can I
so
assume
that
that
can be as like the
1 minute
compressed one can
or
be 1 MB only.
and at any point like the system should be highly scalable for the higher amounts of videos which keeps on being uploaded in its
Correct.
database.
Right.
uh, so like on an average at present some amount of videos we will like some like around 1 million videos, can I assume, are there already on the system?
Uh, yes, you can assume that 1 million videos are there in the system, and at a ratio of like there are 1 million users, and out of that 1 million user, you can assume like 100K users are uploading the videos, right?
100K
Whereas,
users are uploading.
right,
Okay. And 100K users are parallelly uploading the videos. So, okay. Network bandwidth perspective, uh, like I
it's 100
can
MB or
say
maybe
that
a,
100K,
yeah, 100 MB per second.
yeah, 100 MB per second, and here also kind of 100 MB per second. So this will give me a network bandwidth, number of videos into the size of each video will give me the total database size which is required. In addition to that, there will be some kind of a user metadata uh, for the subscribed users,
Right,
and there will be videos metadata as well
correct.
for each of the videos. So this I will draw a rough architecture diagram.
Sure. And feel free to ask any question in between, but this is largely you covered the requirement uh, much clearly, which is possible for this interview. What is your thought
No,
process?
I'm starting with a fresh one. Yeah, I'm starting with a fresh one. These are kind of sketches which I already have drawn, but these are for different systems.
Sure.
Like there will be three kinds of data. One is video. Whenever query is coming,
Jatin, the below one is something what you're designing, right? So you have actor, you have
yeah,
load balancer, and then you have multiple servers.
yeah. So these multiple servers are handling the video uploading request, and there
Okay.
will be a parallel system which will be handling the video downloading request.
Okay.
So, like whenever a request comes, the server will forward it to the queue. This queue will be kind of a persistent queue in which the message will not be lost. Example can be a Kafka queue, and there will be a consumer process which will be reading from the queue and will be taking care of uploading the message, uploading the video, and putting that into a persistent data store. So the persistent data store can be uh, the persistent data store can be a blob storage or a S3 storage.
So you meant to say that you want video file to be stored separately, and its metadata should be stored in the SQL table. Is it what you're saying?
Yeah, so metadata will be stored in a SQL DB once the video is completely downloaded. And this
Got it.
consumer process will also need to be a highly available kind of process.
Mhm.
And if a video is stopped in between, it will it will store it will have its own SQL table where it will store the metadata of the videos which are partially loaded,
Sure.
and will be able to retrieve and will
So
be able to
one question
retrieve
on
it
this
from there.
one, Jatin.
And
One question on this one. When are you converting or compressing the video file?
so basically the app which is there, which will be sending the video file to uh, which will be sending the video file will be compressing it and sending it to the consumer process, so that we utilize a less network bandwidth, and consumer will receive a lesser bandwidth, lesser compressed video size, so that the storage also required will be less.
Okay.
Like I just have an additional question, like this consumer process will be kind of parallelly snooping on the multiple apps which have started the upload, but the upload has not been completed.
Mm-hmm.
So uh, like the upload which happens a second time has to be triggered by the app, or it has to be triggered automatically by a consumer process.
So
So if it
basic.
has to be triggered automatically by a consumer process, it this design will work.
So it is more like rather than server pulling up the request or the data, right? It's the client
Hmm.
who will decide that internet is
Okay.
available now, right? So rather
Hmm.
than server is pulling up this information, it is client's responsibility as soon as the network is available, push up the data to the server.
So there will be certain videos which are uploaded, and there will be metadata stored for those videos, and there will be uh, downloaded into S3 kind of storage. For videos which are not, so I don't need to have this.
And also, I want you to think about the subscription and notification system as well.
Yeah. So with respect to video upload, like always, it has to be like triggered with from the app side. So suppose it triggers app triggers a video upload. It goes to a server. Server assigns an upload client and also populates a metadata for the video. So the client will be managing the upload of the video and will be storing it in the, as and when the data is coming, it will be storing it in the blob
Jatin,
storage.
just one
Suppose
question on this one. Do you think video upload client should be after the server or before the server? It's an important component, but by the time your information reaches to server, it's already uploaded, right?
like the kind of it is initial request will go through the server, and then a client it can be a direct connection with the subsequent process or the subsequent burst of the video streams
Mhm.
can be a direct connection with the upload client.
Okay. And what is the
So
role of the
initially,
server and what is the role of video upload client?
yeah. So the server will be kind of starting the process of the video uploading, and it will be kind of storing the metadata of this video upload in a SQL table. Now, suppose the video is completely uploaded, then the progress of this video will be marked as completed, and the video will be stored in the blob storage. Suppose it is not completely saved, video is not completely uploaded, then it will be marked with a kind of a subscription ID and a video ID, and then whenever a subsequent request is made for a video upload, data can be pulled from the SQL table, and the data, whatever new burst of messages are coming, it will be stored in the blob storage, same blob storage location, and
Sure.
it can start an ending point can be noted in this metadata, and from there only the upload can start. So it can directly communicate with the app, and can order to send the video bus message from a particular point.
Got it.
Uh, the the it will also it is the app is compressing it, so the compression will happen through the app, and the server process will the server process, you can say, it is kind of just an initiator. In this way we will not be able to kind of we will not be having a sticky session with the server. So all the data which is metadata is stored in a SQL table. Even if this server goes down and the next request comes, it assigns a video upload client. So then also the session can start by retrieving the data from the SQL table.
Okay. So are you planning just RDBMS structure, or are you planning no SQL structure as well for the database?
Like with the kind of data we have, we just need to maintain the metadata of the videos, and we can maintain it. Like I like to keep the design simple, so we can just maintain it in a SQL tables, the video metadata and user metadata. There will be many parallel requests coming, like as we estimated. So there will be many parallel requests coming, but SQL tables is able to read those requests in parallel. There will be no updates coming on the existing records. There will be new records which will be coming, so there will be no updates on the existing records. So there will be no locking in the SQL tables. But
But
if
one thing, maybe I just did not put this as a part of a requirement, but in general, these video streaming app, they have like, comment, right? These option on each videos, which means the updates are also happening.
Yeah, so if okay, so on the same record, if updates are happening, or we can maintain those in a separate uh, table, mapping it with a video ID.
Okay,
So if video ID is having comments, multiple, there will be no updates on the comment. So one comment and then another comment, then another comment. So it will be kind of inserts on the same video ID.
got it.
So it can be maintained in a SQL kind of a format. But even if our latency requirements are not being met, because whenever somebody wants to, I have to still draw that. So whenever somebody wants to read the video, so they will there will be video metadata which will be searched, and based on the video metadata, it will provide a link for the video, and the video or they can be for faster access. There can be CDNs which are located in different geographical regions. So here CDNs will be placed based on the location of the user, and the video metadata will provide a location of the URL of the video, and which will directly go to the app, and app will directly access the CDNs. All the directly access the CDNs, and CDNs will be connected through S3 blob storage to retrieve the latest information from the centralized store where the videos are
Got
loaded.
it.
Also, it will be connected with the user metadata to record the information of each of the user of what videos they are accessing, so that later on it can be used for our analytics purpose. Uh, the user metadata also, like it's a kind of a insert. Whenever you read any new thing, it will be kind of a new insert, and it follows a regular structure which will not be modified. So again, this can be utilized. SQL table can be utilized for it. There will be, like if we see it in terms of high availability, the processes which and they are like based on the load requirements, the different. So the one point which we are missing is the notification. So suppose
Exactly. I was coming to that.
I subscribe to yeah. So I subscribe to a user, and user has multiple videos uploaded. So there should be a notification which goes to the user. So it is a kind of a event based system wherein I put those events in a kind of a queue, and like simple SNS kind of a queue. So whenever so it goes to finding out through a metadata where the user, and it will be sending a notification through from that server to that user. So it will be accessing the video metadata and will finding out where the user, and also the user metadata to find out the server and then send a notification to it. Also the subscription event will be registered against the user. So that can be kind of a
Couple of thoughts. One, like when we talk about that, users should have an unblocking experience, non-blocking experience, right? So with this design, when you are planning to have load balancer to put it on the server, right? So server is something like which will go synchronous, and that's you do not use any queue, which is important for this design. Right?